All right, welcome to the 8-3 Concept Guide, Part 1. This section is so important that we're going to break it up into two pieces. This first piece here, we're going to talk specifically about slope. We'll get into the y-intercept part of this lesson in the next part. So what is slope? Well, think about it. Where do you know that word slope? You've all experienced slope. It's got written in here. I won't read it all, but definitely if you've been snow skiing, you've done it. But if you've hiked, if you've gone up a hill or down a hill, what makes something more steep or not? That's what we're talking about with slope. There's not very much slope if it's pretty flat. If it's really steep, there's a lot of slope. It's a higher slope. That's what this is. In math, when we talk about slope, we're basically talking about how much something goes up or down, vertical change, compared to how much it goes left to right, the horizontal change. And if you think about it, that's what we're talking about when you think of steepness as well. So there's this slope formula, which equals the amount of rise over the amount of run, how much it goes up and down compared to how much it goes left and right, or the vertical change over the horizontal change, which leads us to a particular formula. M is the variable that we use for slope. I have no idea why it's M, by the way. Never really known. I've heard some theories, but never been confirmed. So we can say this is the difference of the y-coordinates over the difference of the x-coordinates. And to get more technical with that, here are two coordinates. This is x1 and y1. This is x2, y2. These are two separate coordinates. Coordinate set 1, coordinate set 2. Well, if I take the y2, subtract from the y1, y2 minus y1, over x2 minus x1, that is the formula for slope. And we'll use that here in just a minute at the bottom of the page. Slope has direction. In math, you're always traveling left to right, kind of like when we read or write. We always write left to right or read left to right. And if you're going uphill, we call that a positive slope. If you're going downhill, that's a negative slope. If there is zero slope, it's totally flat. You're neither going up nor down. And if you're going up at all, like if it's barely going up, that's still a positive slope. It's just a small slope. And then if there's a vertical line here, that's like a cliff. It's undefined. Like that guy will be undefined when he hits the bottom of that right there, just as an example. But yeah, positive, negative, zero, and undefined are the way slopes are kind of measured. All right. Oh, and when we say undefined, that means there's no slope. Zero does not mean no. If you have zero money, you have no money, but we're talking about slope here. There's zero slope, that's no slope. There is no slope here. There is a slope, it's zero. We're talking zero. All right, so how do you find slope? Well, let's look at examples 1 through 4. The easiest way to find slope is M is going to equal the amount of rise. How much does it go up? So in this case, to go from this point to this point, it would go up 2. So that's where I went up 2. And up is positive. And to the right, 3. 3 is to the right is positive. So this slope is 2 over 3. It goes up 2 and then over 3. I could have started here and counted, but it would look this way. I would have go down, which is negative, down 2, negative 2. And then to the left, which is also negative, and get negative 3, which of course is the same. It's 2/3. Whether we went from this point to this point, up 2 to the right 3, positive, positive, or down negative, left negative, it all becomes a positive because it's negative divided by negative. This is going to be a negative slope because it's going downwards. I can count this, 1, 2, 3. It goes down 3, negative. To the right, positive, 4. Okay? Or if I started at the other point, it would go up 3, which is positive. And then to the left, 4, left is negative. So either way, negative 3 over positive 4, that's negative 3/4. Positive 3 over negative 4, that's negative 3/4. Now, what happens here? Well, let's count. How much does this go up? 1, 2, 3, 4, 5. Or does I must go down? Actually, I started up here. It goes down 5. And then how much does it go left and right? 0, right? So what happens when there's no horizontal change, there's 0 horizontal change. What happens when you divide something by 0? Well, hopefully you've learned by now that you can't divide by 0. That's the reason why the slope is undefined. There's no slope when it's vertical or when the 0 is on the bottom. Look at number 4. How much does this go to up? Well, none, 0. There's 0 vertical change. It doesn't go up at all to go from this point to that point. How much does it go over? Well, it goes over 5. Now, this is different. What does 0 over 5 equal? It equals 0. And so that's why we can show that a horizontal line, the slope will be 0, always. It doesn't matter how far I went left and right. 0 over whatever is 0. Okay? Now, how to calculate slope given some points right here. Let's consider this my first coordinate, x1 and x2. I'm sorry, x1 and y1, and then I'll call this one x2 and y2. Now, I'm just going to plug this into the formula that's up above, where slope equals y2, in this case 4, minus y1, in this case 2, over x2, negative 5, minus x1, negative 2. I'm not going to color code all of these, but I could do that same pattern every time. So I'm going to do that one more time. y2, in this case that's 4, minus y1, in this case 2, negative 5x2 minus x1, 2. Now I simplify. 4 minus 2 is 2. Negative 5 minus 2 is negative 7. This slope is negative 2/7. The next one, I'm still going to use the same pattern, x1, y1, x2, y2, but now it's y2, which is 2, minus y1, which is 5, divided by x2, which is 4, minus x1, which is 5. Simplify. 2 minus 3 is negative 3. 4 minus 5 is negative 1. I can simplify this further. Negative 3 over 1 becomes positive 3. Picking up the pace here just a little bit. y2, 3 minus y1, which is negative 4, over 7 minus 7. When I simplify this, 3 minus negative 4 is the same as 3 plus 4. That's 7 over 0. But wait, we can't have 0 on the bottom. That's undefined. There's no slope. This is not a function, is another reason why there's no slope. But every time you have, this would be an example of, this would also create a vertical line like these points right here. And then number 8, y2 minus y1 equals x2 minus x1. In this case, I end up with a 0. On top, this would be a horizontal line. The slope is 0. So anyway, those are some examples of how you calculate slope from either a graph or from 2 coordinates, and I hope you'll give that a shot as well. Let me know what questions you have. See you, bye.